Imagine a battlefield centuries ago. Armies clash with swords and shields. Suddenly, a giant wooden arm swings through the air. It hurls a massive stone toward the enemy lines. This, my friends, is the power of the catapult. Catapults were ingenious war machines. They used simple physics to launch projectiles at the enemy. These weapons played a crucial role in ancient battles. They could turn the tide of war with their impressive power. From ancient Greece to the Roman Empire, catapults were instruments of destruction. They instilled fear in the hearts of defenders. But how did these simple machines work? The answer lies in the fascinating world of physics, specifically projectile motion. By understanding the principles of launch angles and trajectory, ancient engineers built weapons of surprising accuracy and power. The angle at which a projectile is launched is crucial. This launch angle determines the distance and height the projectile will achieve. Imagine throwing a ball. If you throw it straight up, it will go high but not far. If you throw it horizontally, it will travel farther but stay low to the ground. Catapults work in a similar way. A 45-degree launch angle is generally considered optimal for maximum distance. This angle balances the upward force with the forward force, resulting in the longest trajectory. Launch angles higher than 45 degrees will send the projectile higher into the air. However, the distance covered will be shorter. Conversely, launching at angles lower than 45 degrees prioritizes distance over height. To fully grasp the power of the catapult, we must delve into the basic principles of physics at play. Trajectory is the curved path an object takes when launched into the air. Gravity, the force that pulls everything towards the center of the Earth, constantly affects this path, pulling the projectile downwards. The initial velocity, or the speed at which the projectile is launched, plays a vital role in determining how far and high the projectile will travel. These three elements, trajectory, gravity, and initial velocity, work in concert to determine the projectile's flight path. A catapult operator, by adjusting the launch angle and the tension in the catapult's arm, could manipulate these factors to control where the projectile would land. The beauty of physics lies in its ability to be observed and tested. You can experience the principles of catapult physics firsthand through simple experiments. Building a small catapult with readily available materials like popsicle sticks and rubber bands provides a hands-on understanding of these concepts. By experimenting with different launch angles and observing the distance your projectile travels, you can gain an intuitive understanding of how launch angle affects distance. You can also see how the weight of your projectile influences the force required to launch it. These experiments offer a tangible and engaging way to learn about the fascinating world of physics.